Enzymes are classified based upon the type of reaction that they catalyze. So remember our good friend alcohol dehydrogenase. Alcohol dehydrogenase is in its own enzyme class because it's an enzyme that catalyzes a redox reaction, said another way, an oxidation reduction reaction. So the first class of enzymes that we'll talk about is that catalyzes redox reactions and that are termed oxidoreductases. That's kind of the fancy name given to dehydrogenases. So let's revisit our good friend alcohol dehydrogenase, and let's actually draw out the reaction that it catalyzes. So if we begin by showing our good friend alcohol, the molecule, and recognizing that this will be acted upon by the alcohol dehydrogenase enzyme in a redox reaction that converts alcohol into acetaldehyde, which is going to be the more highly oxidized version of the molecule. But we're not finished because there's a very epic, and you might have noticed this when we looked at the image from the protein data bank, that alcohol dehydrogenase has some major helpers, and that helper is going to be our good friend NAD+. Those of you who took micro are totes going to recognize NAD+ as being a vitamin-derived enzyme helper, a cofactor, and we're going to talk about types of cofactors here pretty soon. So NAD+ is going to get reduced to form NADH as alcohol is oxidized to form acetaldehyde. So there is the redox reaction catalyzed by ADH. And as it turns out, alcohol dehydrogenase has an even more systematic name, right? That systematic nomenclature coming back in again. We can also term it the name of the molecule, the substrate that's oxidized, colon, the name of the cofactor that's reduced, and then add on to it oxidoreductase. So another name for alcohol dehydrogenase would be alcohol or ethanol NAD plus oxidoreductase, to take a more systematic approach. Another name for alcohol dehydrogenase. So we also have many others that fit into this category, and along our journey of metabolism, we will meet a lot of other oxidoreductases. But for now, let's move along and turn our attention to some of the other classes of enzymes. And let's actually take a look at the transferases. And these are pretty easy to make sense of because these catalyze group transfer. So say if you see a reaction that is catalyzed by a kinase is an enzyme that transfers a phosphoryl group from one substrate onto another. So we're basically just seeing the transfer of a group from one to another. So a group transfer reaction. Now the most famous or most common form of enzyme in the transferase group are hydrolases. Hydrolases use water as the receiving group of the group transfer. So you will see some molecule plus water, and then you'll notice that that water will get an R group added onto it. So it'll go from being water to being like an alcohol, HOR. So a hydrolase is pretty easy to recognize, and again, epically common. So those are pretty easy to recognize, but we will practice. Now I want to look at lyases. Lyases catalyze the lysis of a substrate, and in doing so, they generate a double bond. So I actually want to draw one of these circumstances for you so we can see what we would be looking for when we see a lyase. And it's interesting to note that when lysis of the substrate occurs, it really commonly causes a double bond to be introduced. So let's pull up a blank sheet of paper and see if we can draw one epically cool reaction catalyzed by a lyase. And we're going to begin with our good friend histidine. So we'll just jot down histidine, and perhaps you're already a step ahead of me in getting the structure of histidine jotted down. Doesn't necessarily have to show stereochemistry, or it can right now, whatever you would like to do there. So just our R group here. we'll just show it in the imidazole form. There, that's good enough. Because what's going to happen in this reaction is that what we're going to see is the a lyase working on this to introduce a double bond in this location. So essentially, you're going to see this become now recognize that this would be involved in the breakdown of histidine if it were to enter into catabolism. So essentially we would see that becoming a double bond. And then of course the R group would stay the same, so no change there. And the name of this, and of course recognize that ammonia was lost there. So the name of this enzyme is actually histidine ammonia lyase. That makes a lot of sense systematically, doesn't it? So histidine ammonia lyase. And you can see how that created a double bond. So where we're getting a lysis reaction in which there's a double bond created, we were seeing the removal of the ammonia, the amino group to give an ammonium ion. Now, there are enzymes that catalyze the reverse reaction to what a lyase does, which quite literally means that they're catalyzing a synthesis. So syntases catalyze this reverse reaction where you're basically seeing the addition over a double bond, a reverse reaction of what we just drew. Isomerases are one of my favorites. Many of them are called mutases, and they're really easy to recognize because all they do is to catalyze a rearrangement. And this is super easy to see because it means there's one reactant and one product because there's been nothing lost, nothing gained. It's just been a simple rearrangement, kind of like what you do in your bedroom when you get tired of it. You want to rearrange furniture, but you don't necessarily get something new or get rid of something old. You just rearrange. Now, lastly, and perhaps one that you have heard about many, many times, are the ligases. And remember DNA ligase, the enzyme that knits together the 3' 5' phosphodiester bond whenever there's a nick in DNA. Ligases are catalyzing the joining of two substrates, and sometimes they require energy input in order to do that. Now, we need to do just a little more practice, so I'm going to draw your attention to a couple of practice problems.
Okay, so here's the first one. Basically what we have here is a glucose molecule. We'll be drawing glucose pretty soon when we get to chapter 8 as we talk about carbohydrates. But you guys probably recognize the basic structure of glucose, maybe even remember it from micro. So what happens then in this reaction? We have glucose plus ATP, and we get this molecule. All of these are the same, so I'm not going to draw them all in, but the one difference is right here. Glucose 6-phosphate is what this molecule is. Plus ADP. Okay. All right, go back and look in your notes and determine what type of enzyme catalyzes this reaction. What class does it fit into? Okay, see an ATP molecule, and we see, look at this, the transfer of a phosphate group from ATP to glucose. So this is a transferase. I need to get some music to play as I'm waiting for you to go back in your notes, huh? Okay, great. So let's look at another one here. This one's kind of fun. Got a 3-carbon molecule here. We're going to get to know it a little bit later. And what we see here, okay, so what we see here then is basically a rearrangement, right? Everything stays more or less the same. We have one substrate, we have one product, and we're getting a rearrangement. So this is an isomerase. Cool. And we already looked at our example of a dehydrogenase with alcohol dehydrogenase. You guys can get in the habit as we go through metabolism of determining what class an enzyme fits into as we look at and discuss those individual enzymes.
One of my prior students, his name is Colin, Bruce's own beer, and this was an absolutely favorite gift that I received from him. This is Tiger Booty Wheat, and it was actually quite good. You know, cheers, Colin. But we know right now that alcohol dehydrogenase is the enzyme in the liver that detoxifies ethanol, maybe when we've had a little bit too much Tiger Booty Wheat. We know that alcohol dehydrogenase is an oxidoreductase, and we know what reaction it catalyzes. But what we don't know is how efficient that enzyme is and how much it desires its substrate, alcohol. So we need to learn those things so that next time you're praying to the porcelain goddess, you're going to know exactly what to say to your alcohol dehydrogenase enzyme. You want it to increase its kcat and decrease its km.